Okay, so for this recording, right, we are going to talk about simultaneous equations involving non-linear functions. Okay, so in Sec 2, right, you guys would have learned about solving simultaneous equations with all your linear equations, right? Okay, but then in AMath, there's also this part where we solve simultaneous equation that involves non-linear equations. Okay, basically our quadratic equations are. Okay, so we are going to see how we can solve that. Okay, so before that, right, let's do some recap on our quadratic functions first. Okay, so in our algebraic identities, right, we have learned these three identities, correct? Where we have our a plus b holding squared equals to a squared plus 2ab plus b squared. And then we also have our a minus b squared equals to a squared minus 2ab plus b squared. Okay, and lastly, the a squared minus b squared equals to a plus b multiplied to a minus b. Okay, so these three are the algebraic identities we have done before, right? Okay, then this will be very important in our quadratic expansion when we do the simultaneous equations involving quadratic equations. Okay, so keep in mind, these two are usually used. Okay, so just recall if you have a plus b whole thing squared, then this is plus 2ab. When you have a minus b whole thing squared, then this will be minus 2ab. Okay, and then just some tips over here. When you have a square term like this, negative y minus x whole thing squared. Okay, we usually don't want to start with a negative number. Okay, so what we can do in this case, right, is to factorize out our negative here. Okay, so this then becomes negative 1 times of y plus x, right? Okay, so this becomes this. Okay, then this whole thing squared. Okay, then when you square two things that are multiplied to each other, you are going to square each of them, right? Okay, so when you square negative 1, okay, this then just becomes negative 1 square multiplied to y plus x square, right? This just gives you 1. Okay, so this then simplifies to y plus x whole thing squared. Okay, so just an example. So for example, if you have something like negative 3x minus 2. Okay, when you have two negative signs, right, inside your square, holding square, factorize out your negative sign. So you would have this. Okay, so this then just becomes 3x plus 2 holding square. Okay, then you can just make use of this algebraic identity number 1 over here to expand it out as a squared plus 2ab plus b squared. Okay, where your a is 3x and your b is 2. Okay, then let's say if you have again another negative sign in front, right? But in this case, your second term is a plus, okay, plus x. Then you know in addition and subtraction, right, you can just shift the orders of your terms, right? Okay, so in this case, you can shift it such that it becomes x minus y whole thing squared instead. Okay, then this just becomes your algebraic rule number 2 over here, right? Where you can just expand it as x squared minus 2xy minus plus y squared. Okay, so an example. So let's say if you have negative 3x plus 2 now. Okay, then this, you can just shift your two terms around such that it becomes 2 minus 3x whole thing squared. Okay, then you're just going to use your algebraic rule number 2 again to expand it out. Okay, where your a is 2 and your b is 3x. Okay, so just some tips on how you expand, just a recap. Okay, so when you have 2x plus 3 whole thing square, right, is your algebraic rule number 1, where your a is 2x and your b is 3. Okay, so you're just going to plug it into the formula, okay, the algebraic identity. Okay, with the bracket, so the key thing here is to put your bracket. Because, right, if you write it as 2x squared, this is not the same as bracket of 2x whole thing square. Because this is actually equals to 4x squared. Okay, because you square the 2 and you square the x as well. Okay, so the key thing here is just to remember put all your brackets. Okay, when you expand it out. Okay, and then when you have algebraic rule number 2, right, is when you have the negative here, then it will be negative for your 2ab. Okay, so this is just a recap. Okay, now we go into the main focus of our today's recording. Okay, so when we want to solve simultaneous equations involving non-linear equations, okay, things like our quadratic equation, how are we going to do that? Okay, so usually let's see, for example, our question is to solve simultaneous equation with this two equation, 2y equals to 3x minus 1 and also 4x squared plus 9y squared equals to 15xy. Okay, so when we have these two equations, right? Okay, clearly the first one is your linear equation. Okay, linear equation usually will just have your x and y alone, right? With the power 1 only. Okay, so when you have equations involving, let's say, xy term inside, this is not your linear equation. Okay, or when you have x squared or x cubed involved inside, this is also not your linear equation. Okay, or even if you have 1 over x minus 1 over y equals to 3, right? This is also not linear. Okay, it is only linear if your x and y terms are on top, okay, at the numerator. Okay, so over here, this is your linear one, and this is your quadratic equation. Okay, so when you have these two types of equation, right, how are you going to solve them simultaneously? Okay, so the key thing here is to manipulate your linear equation. Okay, over here, if it's not in the form of y equals to mx plus c. Okay, because, right, recall when you solve for simultaneous equation in Sec 2, right, one of the method is to make y or x your subject, right, in one of the equation and then sub it into the other equation. Okay, then same thing for this. We always start with the linear one and then we make x or y our subject. Okay, so in this case, let's try to make y our subject. Yeah? So we are going to divide throughout by 2. So you will get y equals to 3x minus 1 divided by 2. Okay, then we will make use of these equation instead. Okay, so this is equation 1 and this is equation 2. Okay, then we are going to sub our equation 1, which is linear. Okay, sub the linear one into the quadratic equation. Okay, so that is your step number 2. Okay, so just sub it in. So 4x squared plus 9 times of 3x minus 1 over 2 whole thing squared equals to 15x multiplied to 3x minus 1 over 2. Okay, then just expand it out. Okay, and then over here, right, because you have fractions over here, divide by 2, right? Okay, before that, let's just expand out here first when we have square here. Okay, so when you have a fraction whole thing square, right, you're going to square both the top and the bottom. Okay, so this becomes 4x squared plus 9. Okay, 3x minus 1 whole thing square, right? It's just the algebraic rule number 2. Okay, so this becomes 3x whole thing square, which is 9x squared. Okay, minus, okay, I'm just going to write down the steps. Okay, so you would have 3x whole thing square minus 2 times of 3x, 1 plus 1 squared. Okay, and then at the bottom where you have 2 square, which is 4. Okay, then here you will still have 15x multiplied to 3x minus 1 over 2. Okay, then this becomes simplified to 9x squared minus 6x plus 1 over 4 equals to 15x multiplied to 3x minus 1 over 2. Okay, then when you want to solve for this, right, you don't want to see a denominator. Okay, you don't want to see fraction form. Okay, then we are going to multiply throughout by 4, okay, to get rid of the denominator. Okay, so if you multiply the equation throughout by 4, right, you're going to get 16x squared plus 9 times of 9x squared minus 6x plus 1 equals to, okay, because over here, right, okay, for the first term, you multiply by 4, right, to get 16x squared. For this term over here, when you multiply by 4, you get rid of the denominator here. Okay, when you multiply by 4 to this term, okay, you get rid of the 2 at the bottom, but you still have to multiply by 2. So in this case, when you multiply by 4, okay, you get rid of this, right? There's still a multiply by 2 here. Okay, so don't forget. So here it becomes 2 times of 15x and 3x minus 1. Okay, then you're just going to expand everything. Okay, so this becomes 16x squared plus 81x squared minus 54x plus 9. And then on the other side, you're going to have 90x squared minus 30x. Okay, then shift everything to your left-hand side, right, to make your right-hand side equals to 0. Okay, before you can start solving for your quadratic equation, remember. Okay, so shift everything to your left-hand side. Then you're going to have 16x squared plus 81x squared minus 90x squared minus 54x plus 30x plus 9 equals to 0. Okay, then this then simplifies to 7x squared minus 24x plus 9 equals to 0. Okay, so once you reach this stage, right, because there are a variety of ways to solve for your quadratic equation. Okay, the first way being your factorization. Okay, and then there's also another way where you use quadratic formula. And lastly, also you're completing the square way, right? Okay, so how do you determine which way to use? Okay, you press in your calculator Okay, remember how you solve for quadratic, you can press in your calculator, right? Okay, 5, 2, 2. Okay, then you just key in your coefficients. Then, okay, if you see rational numbers as your answer, right, meaning all your whole numbers and your fraction as your answers, okay, then that means you use your factorization to solve for it. Okay, if you don't see rational numbers, meaning you see all your decimal places, right, all your very long decimal places, then you're going to use your quadratic formula to solve for it. Okay, so in this case, right, when you press into your calculator, you get x equals to 3 or x equals to 3 over 7, right? Okay, these are rational answers, so you're going to use factorization method. Okay, so this becomes x minus 3, 7x minus 3 equals to 0. Okay, so just use your calculator answer, or x equals to 3 over 7. Okay, then don't just stop here. You're solving for simultaneous equations where your unknowns are x and y, right? Okay, so you also have to find what is your y. Okay, then referring back to equation 1, right? Just sub each of these x values into equation 1 to find for your y. Okay, so sub x equals to 3 into equation 1. And then you also sub x equals to 3 over 7 into equation 1. Okay, then you would have y equals to 3 times of 3 minus 1 over 2. Then just key into your calculator, right? You're going to get 4 for this. Okay, and then here when you key into your calculator, okay, you're going to get 1 over 7. Okay, so these two are your answers. Okay, if the questions ask for the coordinates, right, as your answers, then you are going to give it in this form. Okay, if question wants coordinates. Okay, remember your coordinates are in the form of your x comma y bracket. Okay, then the answers will be in this pair, must be in this pair and this pair, this and this. Okay, don't mix up the order. So the first pair is 3 comma 4, and the next pair is 3 over 7 comma 1 over 7. Okay, so if the question was in coordinate form, then your solution should be in the form of bracket x comma y form. Okay, let's do question 1D together. Okay, you realize question 1D, right? It's not like your usual quadratic equations where you can see the quadratic equation directly. Okay, because you have a fraction, okay, such that you see this, right? Your x and your y is at the denominator. Okay, let's see how we can do this kind of question. So as usual, when you do simultaneous equation, right? Okay, identify which one is your linear graph, your linear equation first. Okay, so with this and this equation, okay, you can clearly see your equation 1 is the one that is linear, right? Okay, so we always start by making the linear equation first. Okay, so we're going to manipulate the linear equation such that we get either the x or the y as the subject. Okay, so from equation 1, right? Okay, so from 1, okay, the easiest is to make x the subject, right? Because x is already by itself in the form of x. Okay, so we're just going to shift our 9y to our right hand side such that it becomes 20 minus 9y. Okay, and then we name this our equation 3. Okay, then from here, right, where you have made x your subject already, then you're going to compare between these two equations. Okay, one is your linear one and the other one, which is unfamiliar form. Okay, then when we sub it in, right, when we sub equation 3 into equation 1, okay, and then when you into equation 2, then when you slowly expand it, right, then you will see where the quadratic equation comes out in. Okay, so let us do that first. Okay, when you sub x equals to 20 minus 9y into the x in your equation 2, okay, then you will have 6 over 20 minus 9y plus 4 over y equals to 5. Okay, then in this equation now you only see one unknown y, right? Okay, then when you try to solve for this, now you have two fractions. Okay, equals to some number. Okay, whenever you see this, right, always combine the two fractions into one single fraction so that you can then do your cross multiplication, right? Okay, on your left hand side and right hand side. Okay, so to combine into one single fraction on your left hand side, you're going to make them to have common denominator. Okay, so then you're going to multiply the first fraction by y from at the top and the bottom, and then multiply by 20 minus 9y for your second fraction. Okay, at the top and bottom as well. Okay, then you're going to have 6y plus 4 times of 20 minus 9y. Okay, then they're going to share the common denominator of 20 minus 9y times y. Okay, then over here, you would have 5. Okay, the 5 is the same as 5 over 1, okay? Okay, then over here, then you're going to expand out. Okay, then here you would have 6y plus 80 minus 36y over 20y minus 9y squared. Okay, over here, right, you then see your quadratic already. Okay, you have this y squared term here, right? Okay, so when you cross multiply, you're going to get a quadratic, right? Okay, so over here, let's further expand this. Okay, then over here, when you have a fraction equals to another fraction, right, then you can cross multiply already. Okay, so when you cross multiply, you would have on your left hand side 6y plus 80 minus 36y, and then on your right hand side, you would have 5 times of 20y minus 9y squared. Okay, then you would further expand this out. You have 6y plus 80 minus 36y equals to 100y minus 45y squared. Okay, then shift everything to your left hand side so that your right hand side equals to 0. Okay, then you can solve for a quadratic equation, right? Okay, then shift everything to your left hand side. So you would have 45y squared minus 100y minus 36y plus 6y plus 80 equals to 0. Okay, then you would then have 45y squared minus 130y plus 80 equals to 0. Okay, then over here, right, because it's a quadratic equation, okay, then you can factorize out the common factor and then divide it away, right? Okay, then over here, the common factor is 5. So you can take out the 5. So it becomes 9y squared minus 26y plus 16 equals to 0. Okay, simplify already, right? Then you can divide by 5 throughout. Okay, so on the left hand side, you divide by 5, you get 9y squared minus 26y plus 16. And then your right hand side, right, will just be 0 because 0 divided by 5 is 0. Okay, then the simplest form already, right? Okay, then over here, you can press into your calculator to see whether you get a rational answer. Okay, if you get a rational answer, you can write it in the factorized form to solve for it. Okay, so if you press into your calculator, okay, then you're going to get y equals to 2 or y equals to 8 over 9, right? Okay, so it is your rational answer. So you can write it in the factorized form. Okay, so it becomes this. Then you will know your y equals to 2 or y equals to 8. Okay, then don't stop here. Again, you're trying to solve for your unknowns x and y, right? Okay, then you're going to start back into equation 3 to find your x values. Okay, so let's write it at the side. So start y equals to 2 into equation 3 first. Okay, then you're going to get x equals to 20 minus 9 times of 2, which is equals to 2. Then also start y equals to 8 over 9 into equation 3. Then you're going to get x equals to 20 minus 9 times of 8 over 9. Then you're going to get 12. Okay? So therefore, okay, let's see what the question asks for. Solve the following simultaneous equation. Okay, so they didn't ask for coordinate form. So you can just leave it as, therefore, x equals to 2, y equals to 2. This is one of the answers. Or x equals to 12, y equals to 8 over 9. Okay, so make sure you pair the answers correctly. So y equals to 2 will mean x equals to 2. If y equals to 8 over 9, then x should be equals to 12. Okay, so these two are your answers. Okay, so you see the quadratic equations, right, can also be written in this form, right, where it is not explicitly as your x squared or y squared form. Okay, but when you start in from your linear, the confirmed linear form, right, then you can ultimately end up with your quadratic. Okay, you can see from here already, right, you are going to end up with a quadratic equation. Okay, as you cross multiply. Okay, then the steps will apply accordingly already. Okay, so that is for part D.